Good day. So for the new topic, oblique spherical triangle. So what are the subtopics? So we're gonna have the six different cases, the laws of sines and cosines. Actually, we do have um s- two types of law of cosines. One is for the law of cosines for sides, and then the other one is for angles. Then third, half angle formula. We also have the half side formula, the Napier's formula, and then the D'Alembert's formula. By the way, we're gonna focus more on number two, which is the law of sines and law of cosines for sides and for angles. So we're gonna have problems to be solved using the said laws. The subtopics 3, 4, 5, and 6. So we're just gonna have the list of the formulas. Okay, so for example, so what are the half angle formula, what are the half side formula, so on and so forth. Okay, so it is just more of knowing what are the said formulas. Okay, so for the first subtopic, which is the six different cases, so since we are referring to the oblique spherical triangle, so most likely, okay, so most well, of course, so there are three sides and then three angles. So case one, so if there are given three sides or the SSS, so what can be the formula that can be used here? So how are we going to solve the said oblique spherical triangle? So given three sides. And then on case number two, if three angles are given. Okay, so if three angles are given, so again, how are we going to solve it? This would mean that we're gonna solve for the sides. Okay, then case three, so given two sides and the included angle. So that is the SAS. Two sides and an included angle that is in between the two said sides. Then case number four, given two angles and then the included side. Okay, what is the side in between the said two given angles? The fifth case, given two sides and an angle that is opposite one of them. That is the SSA. And then case number six, so we do have two angles and then a side that is opposite one of the said angle. So we do have AAS. So these are the six different cases. Remember that when we discuss the oblique triangle under the plane trigonometry, okay, during the midterm, so we also discuss the different cases, and it is when we also had a discussion about the laws of sines and cosines. So it will also be the same as the oblique spherical triangle. So there will just a little changes when it comes to the formulas, especially on the law of sines. So as what you can see, so these are the examples of oblique spherical triangle. Okay, so we do have the angles, the vertices A, B, and C. So that is in figure 9.1. Then we do have the sides A, B, and then of course on the lower portion it is actually the side C, and we do have here the height. Okay, the height that is denoted by H. And then in figure 9.2, so you can see here that we do have angle A, angle B, angle C, then angle D. The height is actually the side That is on the right side. Then we do have on the left, which is B. Okay, then we do have at the middle, which is side A. And then also you would try to notice here, you can also notice here that if we do have here the A, B, and then C, so this is side B, this is side A, this is our side C. Okay, so if we do have another portion here, okay, um, so like well, so like this, so we do have here the angle D as what you can see. And if angle D is actually, well, this is a right angle, okay? This angle B here, since the angle B is actually this portion, so the angle in this portion would be what? That is 180 degrees minus the measure of angle B. Okay, because the B is here. This is B. So what would be the measure of this angle? So you have to consider that from this portion, okay, up to this portion, it is 180 degrees. So therefore, this angle here would measure 180 minus angle B. So these are just illustrations of the oblique spherical triangle. So in solving the oblique spherical triangle, so again, we do have laws. So the law of sines and then the law of cosines. So under the law of sines, um, the law of sines, okay, so we have this, well, this description here that the law of sines for spherical triangle is contained in the following theorem. So the first theorem, in any spherical triangle A, B, C, the sines of the sides A, B, and C are proportional to the sines of the opposite angles big A, big B, and big C. That is, sine of side A over sine of angle A equals to sine of side B over sine of angle B equals to sine of side C over sine of angle C. If you're going to remember the law of sines and the, well, in oblique triangle, the one we discussed last midterm period, oblique triangle under the plane trigonometry, what we have last time is the A over sine A equals to B over sine B equals to C over sine C. But then remember, since we already have the spherical trigonometry, so the spherical triangle has sides and angles, okay? Both sides and angles are in degree measure. So that is the reason why when it comes to the formula for the law of sines, so our side here has the sign already. So we have sine, okay? Because the sides are in terms of degree also, same as the angles. Okay, so that is the, well, a little change on the formula. So let us solve an example. Given an oblique spherical triangle A, B, and C with angle B that measures 80 degrees, side B measures 70 degrees, and then side A measures 65 degrees. So what is the measure of angle A? Just remember that the law of sines, okay, the law of sines is used if we do have the pairing. I hope that you remember it. So the law of sines, okay, law of sines, law of sines, this is used if we do have pairing of well, same letter. Okay, same letter. if we have pairing of same letter. For example, we have a big A, a big B, a small b, probably in the given as well as in the unknown. Okay. So with this example, so it is obvious that we do have the pairing of B. So we have a big B and a small b. And then, well, so if this is the case, so it means we can use the law of signs because we have pairing. Okay, so I will switch to the black screen. So what are the given? Again, so we have big B that measures 80 degrees. We do have small b that measures 70 degrees. We will have small a that measures 65 degrees. And then what is being asked? Okay, what is the unknown? The unknown is side A. Okay, again, we have what? We do have the pairing. So if that is the case, so we're gonna use the law of signs. So in the law of signs, so let us write the formula. So what we need, okay? So let us write the formula first. So we have sine of small a over sine of big A. Okay? Sine of small b over sine of big B. Again, so let us take a look at our okay. So let us take a look at the given. Okay? So in the given, we do have big B. We do have small b. We do have small a. And then what is being asked is the big A. So it means in the formula, okay, of the law of sign, so what we need, okay, are these two. Okay, so this is what we are going to use. So we do have sine small a over sine of big A equals sine of small b over sine of big B. Again, what we need is the big A. So let us derive the formula. So in deriving the formula, as what you can see, we do have an equation in which the left and the right are both fractions. So the cross multiplication can be used because we do have fractions. And also knowing that there's no addition or subtraction present. If there's addition or subtraction present, what you can do is transpose. If there's no addition or subtraction and what you can see is only fraction, okay? What you can see is fraction on, well, fractions on both sides or fraction on one side only, well, you can apply the cross multiplication. So let us cross multiply. Okay, so we have on the left, so that is sine A times this sine B here, denominator from the other side. So sine of the big B equals, then denominator of the left side, and then numerator of the right. So we have sine of small b times sine of big A. Okay. You can also write this as sine of small a, sine of big B equals sine of big A times sine of small b. So that is also another way of writing it. Next. So, so let us just rewrite it. So sine small a, sine of big B, sine of small b, sine of big A. And then remember, what we need is the big A. Okay? If that is the case, so we're going to divide both sides with what? The one that we need to move to the other. So it is sine of small b. So divide both sides by sine of small b. Okay? So after that, so as a continuation, so let us just rewrite this. So we have sine of small a, sine of big B over sine of small b equals to sine of small a. You can also write it this way. You can just interchange the two. So we have sine of big A equals sine of small a sine of big B over sine of small b. Okay, you can also write it this way. And then again, so what we need is what? Angle A, because it is the unknown. So what we are going to do, so we need to move sine to the other side. Okay, we need to move it to the other side. Um, so in moving it to the other side, so we'll have sine equals. So sine will become arc sine. Okay. Then you just copy the right side. We have sine of small a, sine of big B over sine of small b. That's it. So you just copy the right side. So this is already the derived formula. Okay, now you can already substitute. So substitute. So A equals to arc sine. So we have sine of small a. Small a is 65 degrees. Sine of big B is 80 degrees. And then sine of small b, we do have 70 degrees. Then you just input it in your calcu. Okay? You input it in your calcu. So we have, just remember your calculator should be in degree mode. So arc sine of 65 degrees times sine of 80 degrees divided by or over sine of 70 degrees. So your answer should be 71 degrees. So it is in the MS format, 71 degrees, 46 minutes and 20 seconds. So this is the answer. Okay. So we'll go back to the PowerPoint. So continuing, we now have the law of cosines for sides. Okay. So this theorem, in any spherical triangle ABC, the cosine of any side is equal to the product of the cosine. Let me just correct this. It should have off. So to the product of the cosine of the other two sides increased by the product of the sines of these two sides and the cosine of the angle included between. Okay, the said sides. So what we have in this theorem are what? So we do have the product also that is separated by increase by. So it means we're gonna have addition. Okay. Then on the last portion, we do have cosine of the angle. Um, when we say cosine of the angle, that is included between the two sides. So this is actually the angle that is opposite of this side here. Okay, the one on the left side of the equation. So by the way, just remember that the law of sines for sides, this is used, okay, this is used if the given and even in the unknown, okay? So we do have three sides, okay? Three sides and one angle. So we make use of the law of cosines for sides. So it means we have small a, small b, small c, and then one angle. It can be the big A, the big B, or big C. So with these four parts that we have here, three sides and one angle. So three parts are given and then one is unknown. So possible we can have the three sides given and then one angle is unknown, or We can have two sides given, one angle unknown, and then one side is, or rather two sides given, one angle is also given, and then the other side is unknown. So as long as there are four, okay, there are four. So when we say four, three given, then one unknown. Okay? So we can have the combination for the given. So two sides, one angle. Okay. So let us take a look. So what will be the formula for this? So for the law of cosines for sides, so the first formula, so as what you can see, so we do have the cosine of side A. That is equal to the cosine of the two other sides, B and C, increased by, this is increased by, so we have plus, the product of the sines of the two sides again, B and C, times cosine of the big A. So if we have here a small a, so on the last portion, we do have the big A. Okay, so this big A is the opposite angle of side A. So just remember this format for B, okay? So for side B, so we have cosine of side B equals to cosine or the product of the cosines of the two sides A and C increased by the product of the sines of the two sides A and C. And then we do have here the big B, okay? Also same format for C. Okay. What is important is you know one formula here, then the others will follow. Okay, you just change the letters. Okay. So let us have the example. Given a spherical triangle A, B, and C with side A that measures 55 degrees, B measures 60 degrees, and C measures 48 degrees. So what is the measure of angle A? Again, we're gonna use, so we're gonna use the law of cosines for sides. Okay. If we do have three sides in the problem and then one angle. So when we say three sides and one angle, so we can have three given, then one unknown. Okay, this is what I mentioned a while ago. So for the three given and one unknown, so we do have the option, so possible, we could have two sides, one angle, okay. Also, we can have what? So possible, we do have three sides that are given, okay. So any of this combination. And if you look at our given here, in the given triangle, so the given or A, or rather small a. So in our problem, the given are small a, small b, and then small c. So automatically, what we're going to use here is the law of cosine for sides. Okay, law of cosines for sides. So let us solve for the big A. So with the three formulas a while ago, so what you need to use is the formula in which the small a, okay, the small a and the big A are present. So it is what you need to consider in using a formula. Okay, so let us switch to the black screen. So we do have the given. So small a that measures 55 degrees, B measures 60 degrees, and then C measures 48 degrees. Okay, so the unknown, so we need big A. So again, what you need in the formula is, well, so considering the small a and the big A. So of course, we do have the formula. So cos, okay, cos of small a equals. You just remember on the right side, you have cos, cos, sine, sine. Then cos again. We just memorize that. Cos, cos, sine, sine, cos. In between the two, in between the cosine, okay, the two cosines and the two sines, so you put plus. Okay, that is the increase by. And then what are you going to write here for the cos and cos? So if you already have side A on the left, so automatic it will be the two other sides here. So B and C as well as on here, B and C. So if you have small a on the left, so on the last portion on the right, so you do have the big A. Okay, next. So what do we need is the big A. So let us derive the formula. So in deriving the formula, as what you can see, we do have addition. So it means what we're gonna do is transpose. Okay, so we do have cosine of side A. So what we need to transpose is of course the term that is what? Well, so that is not with the cosine of big A. Because with big A, we do have sine B, sine C. So what we can transpose is this portion. Okay, this portion. So we have so transpose. So we have cos of small b, cos of small c. So since this is positive on the right side, so moving it to the left, it will become negative. Okay, then equals, you just copy the right side, sine of small b, sine of small c, then cosine of big A. Again, what we need here is the big A. Okay, so let us just rewrite it. So cosine of small a, cosine of small b, cosine of small c equals sine of small b, sine of small c, cosine of big A. So we can already what? We can already divide both sides. We can divide both sides. Because sine B, sine C, cosine A, the operation that is present in the right side is actually multiplication. So to remove sine B and sine C, what we can do is divide. Okay? So divide both sides by sine small b, sine small c. Okay? Then we can already cancel. That's it. So what we have, so let us just write it in this portion. So what we have is what? So we do have cosine of side A minus cosine of side B, cosine of small c, or cosine of side C divided by sine B sine C. Okay, equals. So what will be left on the right side is cosine of big A. This one, it can also be written as cosine of big A equals, so cosine of big A equals cosine of small a minus cosine of small b cosine of small c over sine of small b sine of small c. And then again, what we need is what? We need big A only. So what we are going to do, we are going to move cosine to the other side. So we have big A equals, so cosine will become our cosine, okay? Then just copy the right side. So cosine of small a minus cosine of small b, cosine of small c, sine of small b, sine of small c, like that. Okay. Then after this, you can already substitute. So let us substitute. So we have our cosine. So let us already substitute. So we have A equals to R cosine of cosine. Small a is 55 degrees minus cosine of small b, 60 degrees. Cosine of C, that is 48 degrees. Divided by sine of small b, 60 degrees, times sine of small c, 48 degrees. Okay. Then you input it in your calcu. So again, it should be in degree mode. So our cosine of cosine 55 degrees minus cosine of 60 times cosine of 48 divided by sine of 60 times sine of 48 degrees. Okay. DMS format. So the answer is 68 degrees, 11 minutes, and 58.15 seconds. So that is 58 seconds. We can just have your answer like this. Okay? So that is in using the law of cosines for sides. So let us go back to the PowerPoint. We also have the law of cosines for angles. So the following relations constitute the law of cosines for angles. So these are the formula. So class, if the law of sides, okay, the law of cosines for sides is used if we do have three sides, one angle. The law of cosines for angles, so we're gonna use it if we do have three angles. Okay, three angles and then one side. Okay. And again, with the three angles in one side, so possible in the problem, so three parts are given. Say we do have three angles, and then one side is unknown, or we can have two angles given, two angles given, one side given, and then the other angle is unknown. So you can use this. If you try to notice this law of cosines for angles, this is somehow, okay, well, it might look the same as the law of cosines for sides. But as what you can see, so instead of small letters, you already have the big letters here. So if we have big A, okay, big A, so we do have on the right side big B, big C, okay. Then on the last portion, we do have the small a. Because again, for the law of cosines, we only have what? One side. Okay, one side. So we have a small a. So if we have a big A on the left side, so automatic on the right side, on the last portion, we do have the small one. So we do have the big letter here and then small letter here. So the only difference of this also, okay, another difference of this from the law of cosines for sides is that there is the, well, we do have here what? The negative. We already have the negative, okay, before the cosine of angle B and angle C, or negative before the product of the cosines of the two other angles. So this format is also the same for, well, if we do have the cosine of big B and then for the cosine of big C. So the same format. Okay. Then, so let us use the law of cosines for angles in a problem. So given, so big A that measures 95 degrees, so we have angle A, angle B that measures 84 degrees, and then side C measures 100 degrees. Then we are asked to determine or to find the measure of angle C. So again, as what you can notice in this problem, so we do have big A, big B. Okay? two angles are given, and then the other angle is unknown, and then there's one side given. So we're gonna use here of cosines for angles. Okay, so let us switch to the black screen. So for the given, let us just write it. We do have big A measures 95 degrees. Big B measures 84 degrees. So we do have side C, okay? Side C, small c, measures 100 degrees. And then for the unknown, so what we need here is the big C, okay? So we're gonna use the law of cosines for angles. So for the law of cosines for angles, okay, so let us just write it here. So we have what? We have big A, big B, then we have small c, big C. So automatic, since we have C and big C here, okay, small c and big C, then the two angles. So the big C should be on the left side, okay. So we have here cosine of the big C. Then on the right side, so we have cos, cos, same format, cos, cos, sine, sine, cos. Okay. Then for the cos and cos, so let us write the big B and then the big A. Or if you want to write the big A first and then the big B, it is up to you. It will be the same. Okay. For the sine and sine, so the same, big A, big B. And then for cosine on the last part, since we do have big C on the left, so this will be small c on the right. And then we do have the operation in between cosine, cosine, sine, and sine. So the operation is increased by, so we do have the plus. And then since this is angle, so we do have negative sign because that is a formula. Okay, now let us derive. So let us derive the formula. So in deriving the formula, you take a look at the given. So what is the unknown? The unknown is the big C. Okay, so let us rewrite the formula. So we have cosine of big C equals to negative cosine of big A, cosine of big B, plus sine of big A, sine of big B, cosine of small c. So again, what we need here is the big C. So since the big C is already on the left side, so we're not gonna transpose anything. Okay? So you just what? You just move the cosine to the right side. Okay? So it means, so we have big C equals, so moving cosine to the right side, it will become our cosine. Okay? Then you copy the right side, negative cosine of big A, cosine of big B, plus sine of big A, sine of big B, cosine of small c. That's it. So this is already the derived formula. After this, we can already what? We can already substitute. So we have c equals to our cosine, negative cosine of big A. What is cosine of big A? 95 degrees. Okay, then cosine of big B, that is 84 degrees, plus sine of, so let us just, well, rewrite it so we can have, well, enough space because it is long. So our cosine, negative cosine, 95 degrees, cosine of 84 degrees, plus sine of big A, 95 degrees, sine of big B, 84 degrees, and then cosine of small c, that is 100 degrees. So 100. Okay? Then you can already input this in your calcu. So again, degree mode, so our cosine. So negative cosine of 95 degrees times cosine of 84 degrees plus sine of 95 degrees times sine of 84 degrees times cosine of 100 degrees. Okay, then DMS format for the answer. The answer is 99 degrees, 22 minutes, and 37.11 seconds. So that is 37 seconds. Okay. So for the other for the other subtopics, which are the formulas, so you just you just take note of this formula. So we have the half angle formula. So let us let S equals to 1/2 times sides A, B, and C. Okay, the sum of A, B, and C. Then if that is the case, so the tangent of half of angle A is equal to R divided by sine of S minus A. And then same format for the tangent of half of angle B and then tangent of half of angle C. So these are just giving the half angle formulas. So just familiarization of what are the formulas. Okay? Then for half side formula, so we do have the cotangent of half of side A. So equals to the big R over cosine of S minus big A. Same with the cotangent of side B over 2 or half of side B and cotangent of half of side C. So the same format. Just remember the pattern. Okay? Remember the pattern. Next, we have the Napier's formula. So for the Napier's formula, so we do have the ratio of the cosine of half of the difference of angles A and B divided by cosine of the half of the sum of angles A and B equals, okay, equals ratio of the tangent of half of the sum of sides A and B over tangent of the half of side C. This is, so you can see that we also have, for sine, okay, sine half of the difference of sides A and B divided by sine of the sum, okay, half of the sum of sides A and B equals to tangent of half of the difference of A and B, so the angles, divided by half of divided by tangent of half of angle C. Then so we also have cosines, okay? If you try to notice this cosine, okay, this last formula is somehow the same as this one, the second one. You just replace sine with cosine, okay? For the angles, it will be the same. Or rather the sides on the left side and then on the right side, so the operation in between angle A and angle B will become addition because in the second formula we do have subtraction. Okay, then we have the Lumber's formula. So just take a look at it. Okay, so we have sine half of the difference of side A and C divided by sine of half of side C equals to sine of half of the difference of angles A and B divided by cosine. Okay, half of angle C. So you just take a look at this formula for the lumbers. What is important in this topic again is actually the use of the law of sines and cosines. Okay? So for the law of cosine, so we do have separate formulas for sides and for angles. Okay, so that's it for this topic. Thank you.